Good day everyone, my name is Engineer Mark Kevin Tumalido Sidro, and for today's video, our topic is still on function but we'll focus more on how to find the domain and range of a given algebraic function. Now I know I already discussed this on the previous video, which you can find on the description below, but on this video we'll focus more on how you can do it faster by applying the different techniques that I'm about to discuss. Now, I know some of my students already know what are these techniques because when I go through all of your submitted practice exercises, some are really more advanced than others. But for those who will be seeing this the first time, don't worry, you are still on the right track, okay? So, without further ado, let me introduce to you these techniques, okay? So, we have number one, when you are dealing with a polynomial function. Now, take note, a polynomial function is a function wherein all of the terms of x has an exponent that is a positive integers. That includes 0. So, if all of the exponent of x is a positive integer, then that function is a polynomial function. Okay, so when we are dealing with a polynomial function, we have case number one. If the highest exponent is an odd integer, meaning if the degree of the function is odd, then the domain and range of this function is actually all real number. You don't need to solve. Basta ang highest exponent is odd, then domain and range of that function is all real number always. So case number 2 naman, if the highest exponent is even integer, the domain is still all real number, but the range is, we have there two cases. If AO is greater than 0, and by the way, AO is the numerical coefficient of the highest degree term. Let me explain it later. Okay, so if AO is greater than 0, then our range is from the minimum value of y to the positive infinity. And letter B, if AO is less than 0, then our range is from the negative infinity to the maximum value of y. Okay, let us have an example. Okay, suppose we have these equations. So now look at these equations. On the first equations, the degree is 3. The degree of the equation is dictated by the highest exponent of x. So looking at this equation, the highest exponent is 3. Ibig sabihin, the degree of this equation is 3. Okay, since it's odd, then we can say that the domain and range is all real number. You don't have to solve, you don't have to do anything, you just need to identify the highest exponent of x. If it is odd, then automatic, the domain and range is all real number. The same with this one. Look at the highest exponent, that's 5. It's an odd integer. Then, the domain of this function is also all real number. Now, let me just explain how it came to be. Bakit ang domain and range of these functions are all real number. Okay, suppose, let me just explain, Let me explain the behavior of the graphs of these two functions. Now, look at the function. Okay, the degree of this term, the highest exponent of this term is, of this function is 3. Odd. And the value of AO, take note, AO is the numerical coefficient of the highest degree term. This one right here is the highest degree term because it contains the highest exponent. And the numerical coefficient is 5, positive 5. So, since AO, which is 5, is positive, then it would start on quadrant 1. The graph would start on quadrant 1, okay, here. And it will end at quadrant 3. Basta, nag-crossing siya because positive, odd ang highest exponent ng x, di ba? 3. So kung odd nga nagko-cross ito niya. Let me have another example later wherein the highest exponent is even. Okay, so the behavior of this graph would look like this. It would look like this. Yan. Now this graph would go on there forever. Same here. It would go on this way forever. It would not end, okay? Therefore, your values for x is from the x-axis, looking at the graph of this function, your values for x will be from the negative infinity to the positive infinity. everything from the negative infinity to the positive infinity. So that's why your domain is all real number. The same with the y. Since this graph would just go on forever here, then this graph will also go on forever and that way naman, then all of the values of y on the y-axis, all of the real number would be covered. That's actually from the negative infinity to the positive infinity. That's why your range is all real number. And what you need to do lang naman is to look for the highest exponent of x. If it is an odd, then automatic all real number, the domain and range. Let me draw the graph. Okay, so suppose we have this one. Okay, so how does the graph of this function behaves? Okay, now take note, the highest exponent is 5. That's an odd. But your AO is -1. It has a negative value. Then it would start, the behavior of your graph, it would start at the quadrant 4 and it will end at quadrant 3. And it would behave like this. Let me draw this one. It would behave like this. Ganun. So this would go on forever on that way, and this will go on forever on this way naman. Okay, so if you would see, it's actually all of the values in x, in the x-axis, would be covered by this graph. Okay, that's from the negative infinity to the positive infinity. The same with y. It's also from the negative infinity to the positive infinity. That's why your domain and range for this type of function is all real number. Yung titingnan mo lang naman is the highest exponent of the function. If it is an odd, then the domain and range is all real number. Now, how about if we have this one? Okay. Now, take note that the degree of the function is even. The highest exponent is 4 for this function. The same with this one. Okay, so now this function will fall under case number 2. Diba? Case number 2 siya. The domain is still all real number right here. Okay, all real number pa rin yung domain, but the range will differ. So depende kung ano ang value ng AO mo, if your AO is positive or negative. Okay, suppose we have this one. Okay, let me draw the behavior of the graph. And let me explain what is that y mean and y max. Now take note that the highest exponent is even, that is 4, and the value of your AO is positive. So it falls under letter A. Positive kasi yung AO mo. Take note, pag positive ang AO mo, or the numerical coefficient of the highest degree term, your graph would always start at quadrant 1. Quadrant 1 siya. Okay, then since this is 4, this is even, it would end at quadrant 2. Okay, take note ha. Kanina, kung odd, it would start at quadrant 1, but it would end on quadrant 3. But this time, since this is even, the degree of the equation is even, it would start at quadrant 1, but it would end at quadrant 2. Let me draw the behavior of the graph. Again, I'm not saying that this is the actual graph of this function. I'm just telling you this is the behavior of the graph. Okay, so it would start at quadrant 1 and it would end somewhere in quadrant 2. It would be like this. Okay, so both of the arrows are directed upward. So one of the arrow are directed upward to the right, and one of the arrow is directed upward to the left. Okay, so your x here, all of the real number in x would be covered by this graph, diba? Because this graph would just go on forever. And this way, and this would just go on forever this way. So all of the real number in x would be covered as from the negative infinity to the positive infinity. That's why your domain is all real number also. But for your range would start at the minimum value of y. Ano ba yung minimum value na yan na sinasabi? that minimum value of y is actually this one. Whichever is has the lower value. Okay? So this point or this point, whichever has the lower value. Di pa kadto habaw-baw. Because from this region, pakaliha ubos, you can no longer find any value of y. There are no possible values of y from the lowest value of y pakadiha ubos. So wala nang possible value. That's why your range is from the minimum value of y to the positive infinity. Okay, how about this equation, this function? Let us try to draw. Okay, the behavior of the graph will look like this. Again, this is even 4. The degree of the function is even, but now the AO, or the numerical coefficient of the highest degree term, is negative. Then it will start at the 4th quadrant and it will end at the 3rd quadrant, and it would look like this. Yan, ganyan. Okay, so both of the arrows are directed downward. Okay, so one arrow is directed downward to the left and the other arrow is directed downward to the right. Okay, so when you look at your x, all of the real numbers in x-axis would be covered by this by the graph of this function. That's why your domain is still all real number, diba? But your y, okay, your y is from the maximum value of y. So it's either whichever has the higher value of these two. Dalawa kasi. So from here, this would be your highest value of y downward. That's why from the highest, from the negative infinity to the highest value of y. Okay? That's why that's your range. Okay? So hindi siya the value of y cannot be greater than the y max, because from the maximum value of y pataas, you can no longer find any value of y. Okay? There are no possible values of y anymore. Okay? So that's why your range is from the negative infinity to the maximum value of y. Now suppose we are given with this quadratic function. So the degree of this function is even, and therefore it falls on case number 2. Okay, so the domain of this function is still all real number. Ang kailangan lang natin kunin, we just need to find for the value of the range. Ang range lang. Let us try the first one. So to find for the range, let us try to understand first what is the behavior of the graph of this function. Since the value of AO is positive, that's positive, right? 3. The AO, take note, AO is the numerical coefficient of the highest degree term, and that happens to be 3. Okay, since 3 is positive, then the graph of this function will start on quadrant 1. And since this is even, it would end on quadrant 2. Okay? So your graph would look like this. Now again, I'm not saying that this is the actual graph of this function. I'm just trying to understand the behavior of the graph so that we can identify the value of the range. Okay, so we have here the lowest point here is what we call the vertex, because this is actually a parabola. And in parabola, we have the lowest point, or yes, the lowest point. We call that the vertex. Okay, the vertex. And this is denoted by HK. Your H is the abscissa or the x coordinate, and K naman is your ordinate or y coordinate. And actually, your K here, ang K lang naman yung kailangan natin, because that would be your y mean or your y max. But for this case, since this point is the lowest point, diba? So that is your y mean. Okay, so to solve for the range, you just need to solve for the K. So how do you do that? Now, there are several techniques on how to find for the vertex. You could use you could transform this equation into a standard form, as we have discussed during our synchronous meeting. Or you could also use this formula. Okay, we have here, to find for the value of H, to find for the value of H, you could use this formula. H is equal to negative B over 2A. Now, what are these B and A? Okay, let me erase that first. Let me explain first kung ano yung A at Suppose we have this equation, okay. So first, you have to arrange the degree of this term. So take a look at this one. The degree of this term is 2, the degree of this term is 1, and the degree of this term is 0. So 2, 1, 0. Dapat naka-arrange from highest to lowest degree. And this one right here, your 3 is your value for A. And this one right here, your 2 is your value for B. And this one is your value for C. Okay, so your A is equal to 3, your B is equal to 2, and your C is equal to 1. So applying the formula for H, take note H is equal to negative B over 2A. Okay, so your B is 2, that is negative 2 over 2. Your A is 3. Okay, so your value for H is equal to negative 1/3. That's your value of H. Now, take note, hindi H naman yung kailangan natin. Yung kailangan natin is the value of K, which is your value for Y mean. So, to solve for K, you just need to use the equation and substitute X, your H here, but take note, vertex is denoted by HK, where H is your X and K is your Y. So, to solve for K, you just need this equation, and you will substitute on the X. Okay, let me erase this. You will substitute on X the value of H. Take note, H is actually X. So you would say, we have here, K is equal to 3. Okay, yung copy ko lang here. 3 times your X is negative 1/3 squared plus 2 times negative 1/3 plus 1. Okay, this will be equal to 2/3. This is your value for K, or that is your value for Y mean. Therefore, your range is this one. Your range is 2/3 to positive infinity. This is your range. Okay? That's how you solve for the range. Diba? Ang dali-dali lang naman. Let us try this one. Let's try this one. Okay. Take note, this is your A, yung negative 3. This is your B, and this is your C. Okay, to solve for H, H is equal to negative B over 2A. And this is equal to your negative B. Your value for B is 2, so we have negative 2 over 2, and your A is negative 3. Okay, and this is equal to positive 1/3. That's your value for H. Okay, and to solve for K, you just use this equation. This is equal to negative 3 times your X. You will use the value for H, that is 1/3, raised to 2 plus 2, and your X is 1/3 plus 1, and the value for K is equal to 4/3. So your domain will be, note ha, aliman hiya, this one right here. Take note, bakit ito yung range natin? Because your AO is less than 0, negative baya. Oh, kita your AO is negative 3. Take note, AO is the numerical coefficient of the highest degree term. Since AO is less than 0, negative 3 is less than 0, okay, then your range would look like this. Your negative infinity, I'll write it down here, from the negative infinity to Y max. Therefore, your K here is actually Y max. So it is this is actually 4/3. Of course, bracket. So this is your range for the function, for this function. Okay, so that's how you find for the domain and range of a polynomial function. We have number 2, when dealing with irrational function. Okay, so how do we solve for the domain and range when dealing with irrational function? Okay, we have this as an example. Now take note, on the previous video, if you have watched the previous video, diba, we used the definition of the domain and range in finding for the domain and range of the function. So basically, that's actually we are finding for all the permissible values of x. Now this time, one technique you can use is to, instead of finding for all the permissible values of x, you could try to find for the number which are not permissible values of x. Okay, in finding for the domain, because basically most of the time it's easier to find for the numbers which are not permissible values for x. Okay, let us have this example. Okay, so for example, we have y is equal to the square root of 1 minus x. So this is irrational function. Okay, this function, I mean, the value of y would be undefined if and only if the value inside the radical sign is negative. Diba? Take note ha. Let me this one right here, this is the radical. Okay, the radical sign. I mean the radical sign. And what's inside the radical sign is what we call the radicand. Oops. Radicand. And together, the whole expression is what we call the radical. Okay, so you have to be familiarized with that. Let me erase. Okay, so how do we find for those numbers or those real numbers which are not permissible values of x? Okay, we are trying to avoid a negative value inside the radical sign, or a negative value for the radicand. Okay, we are trying to avoid. So dapat yung radicand mo, the 1 minus x, it should not be less than 0. It should not be less than 0. So it should be greater than or equal to 0. It should not be less than 0. So your x here, solving for the value of x, this will be 1 x. Oh, so your 1 should be greater than or equal to x. Or you could say x should be less than or equal to 1. Your x should be less than or equal to 1. Oh, that's your domain na, actually. So you could say your domain is actually from x, such that x is a real number, but your x should be less than or equal to 1. That's your domain, di ba? Ang dali-dali lang naman. Okay, how do you solve naman for the range? Okay, so how do you solve for the range? Now, if the radicand, take note ha, the radicand is whatever is inside the radical sign. If the radicand is a linear expression, so when we say linear expression, all of the, the highest exponent of x is 1. Okay, so if the radicand is linear, take note, your radicand is 1 minus x. Diba? This is your radicand. Okay, if the radicand is linear, this is linear actually because the highest exponent is 1. Okay, wala namang ibang x dyan. Okay, so this is linear. So if the radicand is linear, then to find for the value of the range, simply substitute the value of here 1, the minimum value of x. Actually, substitute the minimum value of x, which is equal to to 1. Okay, so to solve that, so you have here y. Let me just copy the equation. You have 1 minus x. Okay, so the minimum value of x is 1. So you substitute that to x. This is 1 minus 1. Y is equal to 1 minus 1 is 0. Square root of 0 is 0. Okay, this is your range. Okay, but you have to write it properly. So your range would be y such that y is all real number, but y, take note, this one right here, that's the lowest value for y. So that is, your y should be greater than or equal to 0. Yan. This is the minimum value of y. Minimum, so ibig sabihin, medyo pa mas madako. Okay? From the minimum, that is 0 to the positive infinity, or y should be greater than or equal to 0. So this is your range and this is your domain. Okay, that's how you find for the domain and range of the function. Okay, now let us try to solve for the second one. So, ano yun? How do we solve for the domain? Oh, same lang how. Oh, we just need to make sure that the radicand will not yield a negative value. So to do that, you use your radicand, which is 2x plus 3, and it should be greater than or equal to 0. Okay, it should not be less than 0 because maging negative siya. Okay, so then you solve for x. This will be 2x plus 3. Sorry. So this is 2x greater than or equal to negative 3. And solving for the value of x is greater than or equal to negative 3 over 2. Okay, so this is your minimum value of x. Okay, kay x daw should be greater than or equal to negative 2/3. So your domain will be, let me write it here ha. Your domain will be x such that x is a real number, but it should be greater than or equal to negative 3/2. That's your domain. So how about this one? The third one here. Okay, so let me put it here. Okay. Suppose we have these irrational functions. How do we find naman? Same lang nga process. You equate this time you equate ha, because the radicand is not linear anymore. It's quadratic, diba? The highest exponent is 2. The highest exponent of x is 2. So this is quadratic. The radicand is quadratic. Okay, so let us try to find for the minimum values of x. So we have here x squared minus 1. You equate it to 0. Okay? 0. You equate it to 0, then solve for the value of x. So we have x squared equal to 1. So your x therefore is equal to positive negative square root of 1. Right? Your x therefore is equal to positive negative 1. So there are two values of x. Okay? So if you draw the number line, okay, we have here the positive infinity to here we have the negative infinity, and we have here 0, and you have here the positive 1, and you have here the negative 1. Let me just put a couple of points pa. Negative 2. Okay, so you have here the negative 1 and the positive 1. Okay, there are two values of x. Okay, so paano mo ba hanapin yung domain of the function? Okay, you just try. Okay, basta you know that there are points here, yung negative 1 at saka 1. Okay, so saang region ba dyan yung tinatawag natin na domain? Saan dyan ang domain? Because it could be this region right here. Ibig sabihin from the negative 1 to the negative infinity, or it could be this region right here from negative 1 to 1, or it could be this region right here from the 1 to the positive infinity. Okay, so di natin alam kung saang region. That's why we have to test. Okay, we have to test it. Okay, so we have here y equal to the square root of x squared minus 1. This is our equation. I just copied it here. Okay, now if your value of x is somewhere in this region, okay, ano ba yung value ng y? Take note ha, if your value of x is somewhere on this region, ano ba ang value ng y? So let us try. You have to try. Y is equal to, you have to pick a number on this region. Any number, basta somewhere here on this region. It could be negative 2. Do not pick negative 1 because negative 1 is yung yung boundary mo. It could be negative 2, negative 1 million, basta somewhere on this region. Don't pick negative 1 million. Say for example we have negative 2. When you pick negative 2, we have here negative 2 squared minus 1. Okay, so y is equal to, this is 4 minus 1. Okay, so this y is equal to the square root of 5. Square root of 5 is a real number, di ba? Square root of 5 is a real number. Okay, so ibig sabihin, take note ha, negative 2, we pick negative 2. Negative 2 is a real number and it produced a real number value for y, that is square root of 5. Take note, diba, there are two criteria for you to identify if a number is a permissible value for x. Okay, so ibig sabihin, negative 2 is a permissible value. Ibig sabihin, from this region right here is a permissible values for x. Okay, so that is from negative 1 to the negative infinity. How about on this region? On this region right here. Okay, you would try na naman. Okay, let me erase this one. Okay, so you would pick a number in between negative 1 and 1. Any number. It could be negative 1/2, 1/2, basta any number, but the easiest one is 0. So we have y equal to square root of 0 squared minus 1. So this is y equal to square root of negative 1. That this is not a real number. That's an imaginary number. Therefore, this region right here. Okay, let me use red to indicate that this is not permissible. Okay, so this region right here is not permissible. Hindi nga region. There are permissible values of x. How about this region here? Okay, so let me erase again. You would pick na naman a number on that region, any number at all. So we have here y equal to, let's use yellow, y equal to, so you pick a number, say positive 2. You have here 2 squared minus 1. Y is equal to the square root of 4 minus 1. So this is y is equal to the square root of 3. Square root of 3 is a real number. So ibig sabihin, this region is also a permissible values of x. Now, how would you write that? Okay, adding a region daw, that is negative infinity to negative 1. Negative 1 is included, di ba? Because when negative 1 it value, your value for the radicand is 0. Di ba? Can equate that to 0 to get the value of negative and positive 1. Okay, so ibig sabihin, negative 1 is included. Union with, di ba there are two region kasi? This region and this region right here. So there are two regions. That's why duha gihap nga interval, union of that interval. So this interval, union with, we have 1 to the positive infinity. Yan. This is your domain. That is your domain. Or in set builder notation, you could write it like this. X such that x is a real number, or x is how do you write, less than or equal to negative 1 union with x. Oops, that's not how you write union, huh? Union with x greater than or equal to 1. That's how you write in set builder notation. That's how you write your domain in set builder notation. So this is your domain. Okay, that's your domain. Now, how would you write naman your range? How would you write your range? Okay, so ganito. Let me erase. Okay, now to solve for the domain, okay, take note, diba, kanina, linear, we try to substitute the minimum value of x to the equation to solve for the minimum value of y. We also have to do that here. So this will be y is equal to the square root of, the minimum value is either negative, yes, the minimum value is either negative 1 or 1. Okay, so let us try both. Okay, so this is negative 1 squared minus 1. So the value here is 0, di ba? So when you use naman the positive 1, the value is, you have 1 squared minus 1 is still 0. So ibig sabihin, your minimum value for y is actually equal to 0. Take note ha, this is your minimum value of y. But your solution would not stop at that value for y, okay? Okay, so the next step is to, okay, let me just put it here ha, that the minimum value of y is equal to 0 so that I can erase this one. Okay, now you would not stop your solution there in finding for the range because y is equal to 0. Your 0 is just the minimum value of y. Take note, we are dealing with an irrational function wherein the radicand is quadratic. Okay, so the next step is to use what we call the inverse function. So basically, we just change the position of x and y. So this will be x is equal to y squared minus 1. So ginvalue ko lang x and y. Inverse. Okay, so this will be, you have to solve for the value of y. You have to solve for y. So this will be square both sides of the equation. So this will be x squared equal to y squared minus 1. And solving for the value of y, we have y squared equal to x squared plus 1. So your y is equal to the square root of x squared plus 1. Let me put it here. So you have here y equal to the square root of x squared plus 1. Now, this time, you have to solve for the domain again. But yung domain na masosolve mo is actually the range. Diba? So, kanina, take note ha, we did the inverse function. So, we changed the position of x and y. So, whatever you solve here for the domain, it's actually the range. Okay? Sige. So, solving for the range, same lang nga how you equate x squared or the radicand, x squared plus 1 to 0 and solve for the value of x. So, you have your x squared equal to negative 1. So, your x is equal to the square root of negative 1. Take note, square root of negative 1 is an imaginary number. Ibig sabihin, this is telling you that there is no real boundary for the range. Okay? So, ibig sabihin, there is no real boundary for the range because the boundary or the boundary we solve is actually imaginary. Ibig sabihin, walang number, walang real number ang mag-generate ng negative value of the radicand. There is no number, real number that can make the radicand be equal to generate a negative value. Ibig sabihin, your range, your domain, ngayon mo masosolve din is all real number. Take note, ang domain na masosolve mo here is the range of the original function. Okay? So the domain here is all real number. All real number ang domain niya. Okay? So you would say all real number. So your x such that x is all real number. That is for this equation. But ini nga domain niya is actually the range of this one. Okay? Naintindihan? So you could say that the range is actually y such that y is all real number. And so the domain of this function is actually the range of this function. Okay? But be careful ha. Take note, our minimum value for y is equal to 0. Okay? So take note, basically, this one right here is telling you that the domain of this function is this one. But we found out kanina that the value of the minimum value for y is 0. So you have to change this range. So how do you do that? It's actually, so instead the all real number, it's actually the minimum value is 0 man. So it's actually y such that y is a real number, but y should be greater than or equal to 0. Bakit greater than or equal? Because this is the minimum value. So, ang value of y niya is should be greater than the minimum value. Minimum nga, diba? So, there will be no lower value than the minimum value. So this is your value for the range. This is your range actually. Your y is greater than or equal to 0. That's your range. Okay, so that's how you solve for the range of an irrational function with a quadratic radicand. Okay, then we have the rational function. Rational function is actually easier than the irrational function. Okay, so we have there. So I have here two examples. Let us try to solve this one. The same lang one irrational function. Instead of looking for all of the possible values, permissible values of x to find for the domain, you have to find for the values of x which are not permissible values. Okay, so in here, this equation, your value for the denominator should not be equal to 0. That's the only rule. Dapat yung denominator is not equal to 0 because division of 0 is not permissible. It's undefined. Okay? So, yun yung iniiwasan natin. Yung denominator should not be equal to 0. So, we would say x, you equate it to 0. So, ito. X is equal to 0, then this is your the only real number which is not permissible. Gin-equate lang natin yung denominator to 0. So, your domain will be x such that x is a real number but it should not be equal to 0. Bakit kung maging 0 siya, your value for the denominator is 0, which would generate an undefined value for y. So, this is your domain. Now, how would you solve for the value of the range? Okay, the range usually is what we call the asymptote, the horizontal asymptote. And solving for the horizontal asymptote, you just we have here y is equal to divide all terms on the right side of the equation. Divide all terms by the highest degree term in the denominator. So that is x. So we have here 1 over x over x over x. Diba? So, divide ko lang ang 1 ng x, divide ko lang ang x ng x. That's why you got here 1 over x over x over x. So, this will be 1 over x over 1. Then, substitute a very large number to x. So, this will be 1 over infinity. 1 over infinity. So, this is over 1. 1 over infinity, it's either positive or negative. Kahit positive or negative, the value is 0. 0 over 1 is 0. So your asymptote, your horizontal asymptote is actually y is equal to 0. So this is your horizontal asymptote. This is the only number which is not a possible value of y. So your range will be y such that y is a real number but it should not be equal to 0. This is your domain and this is your range. Okay? So that's how you solve for the domain and range if the given is a rational function. How about the second one? Let us try to solve. Okay, suppose we have this one. Same lang how, di ba? Same with what we have done here. We equate the denominator to 0 because we are trying to avoid the denominator to be equal to 0. So, hanapin natin ano ba yung value ng x wherein the value of the denominator will be equal to 0. So, you have to equate it to 0. So, this is 2x plus 3 equal to 0. So, this is 2x. Solving for the value of x, this is negative 3. Your x, therefore, is equal to negative 3 halves. Okay, this value of x is the only real number which is not permissible value of x. So your domain will be x such that x is a real number but it should not be equal to negative 3 halves. That's your domain. Now, how do you define for the value of the range or the asymptote again? Now, take note divide all the terms by the highest degree term in the denominator. So this will be y is equal to x na, divide all the term by x. So for example, if this is x squared, divide all the term by x squared, because this is the highest degree term. If this is x cubed, divide all the terms in the right side of the equation by x cubed. Okay, so since that is x lang naman, so this will be x over 2x over x plus 3 over x. And this will be y is equal to 1. X over x is 1. Over 2x over x is 2. Plus 3 over x. Okay, then substitute a very large number, 2x. So this will be 1 over 2 plus 3 over infinity. Okay, 3 over infinity is 0. So let me erase this one. This is actually equal to 0 because 3 over infinity is 0. So your y is equal to 1/2. So that's your value for y. I mean, that's your asymptote, the horizontal asymptote. This is y is equal to 1/2 is your horizontal asymptote. So how do you write your range? This one right here is the only real number which is not a possible value for y. So that's the only exemption for y. So your range will be y such that y, all real number, but y should not be equal to 1/2. That's how you solve for the domain and range of a rational function. Okay, so these are the techniques in solving for the domain and range of an algebraic function. Okay, thank you for watching.